Welcome to wpi.edu/listen, your go-to audio news and podcasts for all things Worcester Polytechnic Institute. After you've listened in, check out our other episodes and dive deep into the exciting news stories shaping the WPI community. Tuesday, October 14, 2025. WPI researchers send experiment to space aboard Blue Origin spacecraft. Heat transfer technology from Jamal Yagoobi's lab could effectively and non-mechanically cool electronics on spaceships and satellites. A WPI experiment, focused on a new way to prevent electronics from overheating, flew into space. September 18, 2025, aboard a Blue Origin spacecraft, giving researchers led by Jamal Yagoobi a critical opportunity to advance their technology by testing it in zero-gravity and multi-gravity settings. The uncrewed suborbital flight lasted just over 10 minutes, including slightly more than 3 minutes of weightlessness, and carried more than 40 scientific and research payloads. Blue Origin's new Shepard spacecraft blasted off and landed at a site near El Paso, Texas, while Yagoobi, the George F. Fuller Professor of Mechanical Engineering, watched a live webcast of the flight in his multi-scale heat transfer laboratory with students who had worked on the WPI experiment. Many people, including students and collaborators at NASA, deserve credit for working hard on this project during the years leading up to this mission, says Yagoobi. The results of our experiment aboard the flight confirm that our design can significantly reduce the surface temperatures of electronics in zero-gravity and much higher gravity conditions. Because of the excellent results we obtained, we are very close to commercializing our electrohydrodynamic cooling technology, as our project has reached a new level of maturity as designated by NASA's Technology Readiness level. The project, funded by NASA, sought to address an out-of-this-world challenge that could have implications for future spaceships and satellites. On Earth, liquids boil upon encountering hot objects, and vapor carries away the heat, making boiling a liquid an efficient way to cool heated items. However, in space, where there is no gravity, vapor bubbles cannot rise from a boiling liquid, and heat does not dissipate effectively or at all. To enable heat transfer in small spaces to avoid overheating, Yagoobi and his team adopted an electrohydrodynamic approach. Yagoobi's gravity-independent hardware improves two-phase, or liquid vapor, heat transfer by extracting vapor bubbles away from a heated surface during boiling with a dielectrophoretic mechanism, which leverages an electrical field to move bubbles. This thin-film boiling technology is a thermal management system that acquires heat non-mechanically at higher rates while consuming negligible power. NASA's Goddard Space Flight Center collaborated with the WPI team to fabricate parts for the experiment, which was vacuum-sealed inside a metal chamber and housed in a locker that measured about 24 by 24 by 18 inches. Yagoobi traveled to Blue Origin's Texas site in August, with PhD student Matthew Catuccio and Alexander Castaneda, PhD class of 2025, to install the final pieces of hardware on the experiment. Two others in Yagoobi's lab, Nate O'Connor, PhD class of 2023, and PhD student Lindsay Podlaski, have also worked on the project. I am extremely grateful to have been a part of this project from its early stages to now, says Castaneda. To see it fly on a rocket into space is extremely rewarding, and feels like the next step to pushing the technology readiness of this project. I am hopeful that the data from this experiment will lead to many more space launches for our laboratory at WPI. Castaneda joined Blue Origin as an employee in September. As an individual, this has been an incredible opportunity to work on a very cool experiment that got to go to space, says Catuccio. It is truly a once-in-a-lifetime experience. I also know this experiment is a major step forward for the laboratory. The technology being tested is very innovative and has the potential to reach integration into real application very soon. Yagoobi has been exploring the problem of cooling in space for over 30 years, both on Earth and in the skies. He, his PhD students, and his collaborators at NASA have tested earlier versions of their technology aboard several of NASA's parabolic flights, in which airplanes repeatedly climbed and plunged through the skies to produce 20-second bursts of weightlessness. Yagoobi also had a different experiment aboard the International Space Station for more than a year. The work was supported by the Biological and Physical Sciences Division in the Science Mission Directorate at NASA headquarters under NASA grants NNX 16 at 09G and 80 NSSC 22K0676. Blue Origin is a privately held spaceflight company owned by billionaire Jeff Bezos. The flight was the 35th and final mission for New Shepard, an autonomous and fully reusable rocket and capsule system built to fly people and payloads beyond the Kármán line, the boundary of outer space 62 miles above the Earth's surface. Yagoobi continues to be passionate about space as reflected from his continuous engagement with NASA's Goddard and Glenn Research Center. "When I was young, I dreamed about being an astronaut and traveling into space," he says. "It has been very rewarding to work on this and other projects with so many students, researchers, and engineers who share my lab's vision of contributing to space exploration."